get right into it. And now we're going to start describing how we really get into these more complicated calculations in equilibrium. So to describe that, we're going to look at a little scenario here. Okay, so we have the following equilibrium reaction. Ozone, O3, plus nitrogen monoxide, NO, is in equilibrium with NO2 and O2. Here we can write the equilibrium expression for that, right? Products divided by reactants. And suppose the equilibrium constant for this equals 16. Okay. And so now if we set up some type of initial conditions, right? We're starting initially with 9 molar ozone and 12 molar nitrogen monoxide and 0 molar of our products. So we're doing this like a traditional chemistry reaction, right? We're starting with all reactants and no products. Okay. So now let's say, suppose 5 mole per liter reacts. And when we're saying 5 mole per liter of what? Well, it would be of everything because if you look at this in our balanced reaction, it's a 1 to 1 to 1 to 1 ratio. Okay. So if 5 mole per liter of ozone reacts, let's say, right? So if we had 9 to begin with and 5 reacts, we're left with 4. Similarly with nitrogen monoxide, if we have 12 molar initially and 5 mole per liter reacts, we're left with 7 molar. And then, of course, if we start with 0 of our product, both NO2 and O2, and 5 molar reacts, we add 5 molar to those concentrations. And so then it would appear that these are our new equilibrium concentrations. Okay, so then let's answer this question. Do these new conditions represent equilibrium concentrations? So how could we do that? Well, we would plug all of these into our equilibrium expression and see if it equals the equilibrium constant. Okay, so to do that, we would say, 5 times 5, right? I'm substituting in values for these symbols. 5 times 5, all divided by 7 times 4. And hopefully you can see right away that's not going to equal 16, right? So 5 times 5 equals divided by 7 equals divided by 4 equals. Yeah, and so you can see this does not equal 16, so no. These cannot represent equilibrium concentrations. So how do we do it? Well, as you might imagine, when we have some unknown quantity that we need to solve for, we use X. So now what we're going to say instead is suppose X mole per liter reacts. Okay, and so now we need to figure out what is that value of X so we can figure out just how much reacts. Okay, so let's do that. All right, so now when we plug all of these things in, we're just going to plug in our new conditions. Okay, we're still starting with the same initial conditions, 9, 12, 0, and 0. But now we're saying suppose X reacts instead of 5. So instead of 9 minus 5 to equal 4, we just have 9 minus X. And similarly, instead of 12 minus 5 to give us 7, we just have 12 minus X. And then, of course, with our products, we just have X and X. Okay, so now let's plug those in. So that's going to go as X times X, all divided by 9 minus X, times 12 minus X, and that all equals 16. And now we have to solve for X. Okay, so let's do that. So the first thing we're going to want to do is rearrange this and expand this FOIL, right? First, outside, inside, last. Okay. FOIL it. And we're going to have to rearrange this to be in the form of the quadratic equation to solve it. Okay, so let's do it. So first, that's going to be an x squared on top. So on the bottom, we remember it's first, and so that's going to be 9 times 12. Let's do that math. 9 times 12 equals 108. Okay, so we did first outside, so that's 9 times minus x, so that's minus 9x. Inside, so that's minus x times 12, that's minus 12x. And then last, so that would be plus x squared. And of course, that all equals 16. So now we've got to keep doing some algebra, okay? So I will combine the 9 and 12x just right here. So we know minus 9 and minus 12 is going to be minus 21x, right? Assuming that I can still do math. It's in the morning time. I haven't had enough coffee yet. Okay, there we go. So minus 12x, or excuse me, minus 21x. And now what I'm going to do is multiply everything over to this side. Okay, so now that's all x squared equals 16 times the quantity 108 minus 21x plus x squared. So we're going to keep going with this thing. I'm going to work this all out so that we can really make sure we're all on the same page. So 108 times 16 equals, so now let's keep that going over here. So I'm going to say x squared equals, so that's 1728 minus, and now I've got to say 16 times 21. Let's see, 16 times 21 equals, so that's 336, so that's going to be minus 336x. And then now 16 plus x squared. Okay, and so now if you recall, we want to get everything set equal to 0 to do this quadratic equation. So when I subtract that over, that now becomes 0 equals, and so minus x squared minus 16x squared. So that's going to be 15x squared minus 336x plus 1728. And now we can plug this into the quadratic equation. I'm going to sing a little song for you that I learned when I was in high school to know that you get the quadratic equation correct every time. So here it goes, and I'm going to write it over here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, that was terrible, but I still remember the quadratic equation. I learned that song when I swear I was like 15 or something, and I still remember it. Okay, so in the quadratic equation, right, when we did this formula, we know that this number 15, that's A, this 336, that's B, and this 1728, that's C. So now we can plug all this into the quadratic. So x equals, so negative b, so that makes it a positive 336, plus or minus the square root of, so b squared, let's just do that, oops, I already had it in the calculator. 336 squared, oh my God, that's a big number, 112,896 minus 4. Let's just do all that together. So we'll say times 4 times A, which is 15, times C, which is 1728, equals, okay, good. So let's see, I'll erase that. And so now that's 103,680, and the square root of all of that, all over 2 times A. 2 times A is 2 times 15, which is 30. Okay, so now let's keep going. Let's calculate what's inside that square. So I'm going to say, let's see here, 112,896 minus 103,680 equals, so that number right there, and I'm going to take the square root of that number. All right, so 96. So now that's 336 plus or minus 96 all divided by 30. So we're going to have two roots for this thing. Okay, hopefully I don't run out of room on my page here. So let's do the positive root. 336 plus 96 equals divided by 30. Okay, so now we can say that x equals 14.4, or, so now let's do the minus root. So 336 minus 96 equals, and then now divided by 30, okay, and that equals 8. So now if we look at our two solutions, x equals 14.4 or 8, and we have to remind ourselves, what were we doing in the first place? We're trying to solve the value of x to figure out what these new conditions are. Okay, so hopefully you can see that the answer has to be 8. It can't be 14.4, because if I do 9 minus 14.4 or 12 minus 14.4 up there, then I'm going to get a negative number for my concentration, and that's no good. Okay, so the solution has to be 8 because I can't get negative concentrations. And so now that I know that that's 8, we can plug in 8 to each one of those values of x. And again, I'm sorry I ran out of room here. But what that means for our new equilibrium concentrations, okay, so ozone is going to equal 1. You can see 9 minus 8 is 1. Let's see, NO is going to equal 4. So we'll put units, molar and molar. And then now we can say NO2 is the same as O2, which is 8 molar at equilibrium. And so now we could even test to see that we got these concentrations correct by plugging them back into the expression. So let's do that. So we know NO2 and O2 are both 8. So that's going to be 8 times 8. And then we know O3 is 1 and NO is 4. So divided by 1 times 4. Okay, check it out. 8 times 8 is 64. Divided by 4 equals 16. Hallelujah. These are the right equilibrium concentrations. Woo!